Alright, welcome to set 6, all about solutions. Now this is going to be a very, very brief introduction to solutions. We'll get into some more complex ideas of solution chemistry when we get later on into the year. But let's go ahead and talk about this nonetheless. Most of chemistry takes place in solution, and that shouldn't be a surprise to you if you are familiar with your previous chemistry experiences. We were always mixing liquids together, or things that were dissolved. Specifically things that were dissolved in water, because water is the universal solvent. If we want to do a really nice chemical reaction, we'll often dissolve solids in water, then mix the two together. And you'll see why later on in the year. Mixing things with water is the best way to tap into their chemical properties. Let's go over what the different parts of a solution are. Here is a very poorly drawn beaker. And inside of it, I have these little red particles, and then obviously a water line here to represent water. Things that are dissolved are called the solute. Okay, the solute is stuff that is dissolved. Whatever the substance is that does the dissolving is called the solvent. Ooh, I made a mistake there. I apologize. Let's fix that. The stuff that does the dissolving is called the solvent. Okay. It's usually water, but it can be anything, as long as it's in a aqueous or liquid state. We can measure how much stuff is dissolved by a concept known as molarity. Okay. Specifically, molarity is the amount of moles of solute dissolved in a given volume in liters. Alright, so to repeat that, molarity, which is a measurement of how much stuff is dissolved, is a measurement of how many moles of solute is dissolved in the or per liter of solvent. The moles can be of any substance or compound, and so could technically the liters of the solvent, but typically with molarity the solvent is going to be water. We also know molarity, which is given the letter a big M, as concentration, and I'm sure you've probably heard how concentrated things might be. For instance, if you have ever had like a very strong orange juice or very strong lemonade, it's very, very concentrated with the citric acid, and you typically have to dilute lemonades down with water to make them easier to drink and less sour. You might have also experienced your soda getting watered down by letting the ice melt in it. When the soda is first poured into the drink, it is very concentrated. It's fresh the way the factory made it. But if you let the ice melt in it, then you will water it down and it will be less concentrated. Soda, when it's first open, will have a higher molarity because it's more concentrated than soda that is watered down because it's less concentrated. So high concentrated things have high molarity. Low concentrated things have excuse me, low molarity. Let's go over 3 problems on how to solve for molarity, and then we'll call it quits. This is a very, very short section. What is the concentration? Let's get this to focus first. We're going to behave. There it goes. What is the concentration of 3.5 moles of iron 3 nitrate dissolved in 7 liters of a solvent? How are we going to go about this? Well, it's asking us for what? It's asking us for the concentration. So we need concentration. From the other page, we know that the concentration is equal to the molarity, which is a big M. And what is molarity equal to? Moles of solute divided by the amount of liters of solvent. And now we just need to go in and plug in the numbers. The problem said we had 3.5 moles. And then we had 7 liters. Now we need our calculator. Now I can do this in my head, but for those of you that need to see it put out on a calculator, I'll go ahead and do that. 3.5 divided by 7 is 0.5. Now, how many significant figures are we allowed to have? Well, there's 2 here and 2 here, so we need 2. 0.50 moles per liter, or you can write it as 0.05 big M, which is molar. Either one of those answers are correct. I think it's a little bit better if you leave it out this way. In fact, on the AP exam, they're going to want to see that more. Alright, so that was pretty straightforward. Let's go to a case where we're going to have to do something fancy. What is the molarity of 8.2 moles of a solute dissolved in 25 milliliters of water? Okay. So it's asking for the molarity, which you know is moles per liter, and it gave us the moles. That's 8.2, and it gave us the volume in milliliters. We can't use milliliters. What are we going to have to do to those milliliters before we can solve this problem? We're going to have to convert those over to liters. Alright? And we're going to go ahead and do this all in one step. So we know that the moles, we know that we have 8.2 moles and 25 milliliters. Okay? How do I get the milliliters over to liters? Well, I have to multiply by a conversion factor. And what is my conversion factor? Well, in order to cancel out this milliliters, I'm going to need a milliliter up here. And then my liters are going to be down here, because we eventually want the liters on the bottom. Now what we'll do is, there are how many milliliters to 1 liter? There are 1,000 milliliters to 1 liter. These cross cancel. And now we just need to do the math. 8.2 times 1,000 is 8,200. 25 times 1 is 25, and the units are moles per liter. Now we need to divide 8,200 by 25, and then that equals 328 moles per liter. Now I did it in such a way where I did the conversion between milliliters and liters all in one step. Some of you guys might have had the idea to do the milliliters to liters conversion off to the side first and then plug in, and that's totally fine. You would have gotten the same answer. In fact, I'm going to go ahead and show it to you that way as well, so that you can see that both ways will give you the same answer. So let's say we had 25 milliliters. We need to convert those to liters. You know that there are 1,000 milliliters to every 1 liter. These cross cancel. 25 divided by 1,000 is 0.025 liters. You know that molarity is moles per liter. It's 8.2 moles for every 0.025 liters. If you were to divide that out on your calculator, 8.2 divided by 0.025, you would have got 328. Now, I should have paid attention to significant figures in this, but I didn't. If we were paying attention to significant figures, we would need to round this to 330 molar, because we are only allowed 2 significant figures. Same thing right here. And 330 only has 2 significant figures. Let's do our last example. We'll call it a day. What volume does 9.1 moles of a 6 molar solution occupy? Whoa. Now this one's a little different. What is it asking for you this time? It's asking for the volume. Okay. Now let's start with our molarity expression, moles per liter. It's asking you to find liters, because that's what volume is. It gave you the moles and it gave you the molarity. So it gave you this and it gave you that. Now it's telling you to find this. We're going to need to use algebra to manipulate this equation so that we can find the liters. Now you should be good with algebra by this point. Alright. If we arrange this expression algebraically, we would multiply the L by both sides. Both sides take the L. No pun intended. And you would end up with that. Liters times molarity is equal to mole. Divide by molarity on both sides. Liters is equal to the moles divided by the molarity. And now we're in business. We can just plug in 1.9 moles over 16 molar. Now I would break down molar into moles per liter. The reason why is because these cancel. And now we plug it into our calculatrice or calculator. Uh, 0.56875. We are only allowed 2 significant figures, so it would be 0.57 liters. And that is it. Alright, ladies and gents, that's all I have for you with the solutions. Go ahead and try out the summer assignment. It's a pretty short section, and we'll get a little bit more complicated with solution chemistry later on in the year. Alright, we'll see you now for set 7.